Welcome everyone. We are discussing integration by parts. We have already solved basic problems of integration by parts. Now this is my second class. Today I will solve some important problem of board as well as problems of competitive exam. So let us start. Tan inverse root x, sin inverse root x, cos inverse, cosec inverse, they are of same type. So suppose sin inverse root x dx. So only one function, you have to differentiate it then into one as integrable function. But if you use this method, then you have to differentiate sin inverse root x. Derivative is difficult. 1 by root under 1 minus root x whole square ddx of root x. So to omit root over, we put a transformation. We make simplification first. So what is the simplification? X equals to z square. So dx equals to 2z dz. So now this is sin inverse z into 2z dz. So argument is simple. That is z. Now we use the same rule, Liet rule. This is inverse circular and this is additive. So this as first function, this as second function. So rule is sin inverse z unchanged integration 2z dz minus d dz of sin inverse integration 2z dz, total bracket this, that is integral of this part. Now sin inverse z, it is z square, 2z, integration of 2z, z square, minus 1 minus z square. Argument is z, so only 1 minus z square. This is z square, dz plus c1. Now, this is z square, this is 1 minus z square. So, we put transformation. Root over 1 minus z square. So, z equals to, you know, sin theta or cos theta. So, dz equals to cos theta, theta. 1 minus z square. If it is 1 plus z square, z equals to tan theta. So z square sin inverse z minus 1 by 1 minus sin square theta. This is z square sin square theta and cos theta d theta. Dz is cos theta d theta. So 1 minus sin square theta root over cos square. So this and this is cancelled out. So finally we are getting this is sin square theta d theta, because cos theta and root over 1 minus sin square theta is cancelled out. Plus c1 plus c1. Now we know this is sin square theta. So we have to express it in terms of multiple angle. 2 sin square theta, 1 minus cos theta d theta plus c1. Now 1 is integrable, cos theta is integrable. So what we are getting, z square sin inverse z after this step half, then bracket theta minus sine 2 theta by 2 plus C1. C1 plus C2, that is, you make it C. Now we want to express it in terms of original variable. So z square sine inverse z on z half. What is theta? Sine theta equals to x. So theta equals to sine inverse x, and it is 2 sine theta cos theta plus so z square sine inverse z minus half sine inverse, this is not x, this is z, sorry, sine inverse z, 2 to cancel. So this is z sine theta, and this is 1 minus z square plus c. So this is in terms of z. Now you have to replace z in terms of x. So what is z square? Z square is x. X sine inverse root x minus half. This is sine inverse root x. What is z? Root over x. And this is 1 minus x plus c. So this is expressible in terms of original variable x. So this is final answer. So if argument contains root over cube root, we put substitution, then integrate it by parts. So 1 and 2, they are exactly same. Next, 3, 4. So sine inverse x by root over 1 minus x square. X sine inverse x by root under 1 minus x square dx. So 1 minus x square within root over sine. So we put transformation to omit root over. So obvious transformation is x equals to sine theta or cos theta. So dx equals to cos theta. So what is x? Sine theta, and sine inverse x is theta. This is 1 minus sine square theta cos theta dθ. So 1 minus sine square cos square, so cos cancel, theta sine theta. So this is our first problem of previous class. So very simple. So trigonometric and algebraic. So it has first preference. That is, theta can be considered as first function. So theta unchanged. Integration of sine theta is cos theta with negative sign. Minus derivative of theta is 1, and this is minus cos theta given d theta. Omitting one step. Plus C1. So minus theta cos theta plus cos theta d theta plus C1. So minus theta cos theta plus sin theta plus C. So C1, this is C. Suppose integrating you get another constant. So C1 plus C2, that is C. Now convert theta in terms of x. So what is cos theta? Theta is sine inverse x, sine theta x, and what is cos theta? Root over 1 minus x square. And integration of cos theta is sine theta, so sine theta is x plus. So theta cos theta. So cos then sine theta is x. So this is our final answer. Most important problem of board. Now fourth one, you complete it. 1 minus x by 1 plus x. So you have to put transformation. So suitable transformation is, you know, x equals to cos theta. So dx equals to minus sin theta d theta. So after this step, so tan inverse 1 minus cos theta, 1 plus cos theta. So you must put value of dx. This is minus sin theta d theta. So what is our main aim? To express root over sin in terms of tan, 2 sin square theta by 2, 2 cos square theta by 2 into minus sin theta. So tan inverse tan theta by 2, then minus sin theta d theta. So minus outside. So tan inverse tan absorb. So if no restriction is given, we suppose tan inverse tan x is x. So half into theta sin theta. So minus half outside theta sin theta d theta. This is previous problem. Now you complete the rest of the part. We have already integrated theta sin theta d theta. So 3, 4. Then problem number 6. Sin inverse x by a plus x dx. This is sin inverse x by a plus x. So we have to put transformation. We know if it is x square plus a square within root, then we put x equals to a tan theta. But it is x. So we put x equals to a tan square theta because it is x. If we take a common, 1 plus tan square, this is sec square. We can simplify it. So what is dx? 2a tan theta into sec square theta d theta. 2a tan theta sec square theta. So sin inverse a tan square theta, a common 1 plus tan square theta. Now put dx, 2a tan theta sec square theta d theta. So a cancel. Sin inverse sin theta by sec theta, 2a tan theta sec square theta d theta. Now sin inverse, this is tan theta by sec theta, sorry. So tan by sec is sin theta. So this is our main aim, to put it in simplified form. So 2a outside, theta tan theta sec square theta d theta. So a outside, suppose 2 theta tan theta sec square theta d theta. Now you have to integrate it by pass. So look, 2 theta tan theta sec square theta. So tan theta sec square theta d theta. So this is integrable function. If we put tan theta equals to z, then it will be dz. So tan theta equals to z. Look, then this is z sec square theta d theta is dz. So this is z square by 2. So this is what is z? Tan square theta by 2. So integration of tan theta sec square theta is tan square theta by 2. Tan square theta by 2. So if we take 2 here, then what is the integration of this part? If we take here 2, so this is tan square theta. So we know integration of this part. This part is 2z dz, z square dz. So tan square theta by 2. So this function theta as first function and this is second function. So this is typical problem. You have to recall this. Now A, integration of 2 tan theta sec square theta d theta minus d d theta of theta 2 tan theta sec square theta d theta total bracket d theta. A into, we have already solved it. This is tan square theta. This is theta, derivative of theta is 1. This one is tan square theta, d theta plus c1. Now it is very simple. Express tan square theta. We do not know integration of tan theta, but we know integration of sec square theta. So A outside, tan square theta minus integration sec square theta minus 1 d theta plus c1. So A tan square theta minus sec square theta, this is tan theta plus theta plus c. Now put sec square theta integration is tan theta. Now put what is tan square theta? Tan square theta is x by a. X by a. So here it is theta unchanged, sorry, a outside, sorry, theta unchanged, 2 theta tan theta. So this one is theta unchanged, theta. So this is tan square theta. Then this is 1. Okay. This is theta. So what is theta? Tan square theta equals to x by a. Tan theta. So look, tan square theta equals to x by a. Tan theta equals to root over x by a. What is theta? Tan inverse x by a. Now this is root over x by a. What is theta? It is again theta, tan inverse root over x by a plus c. So minus minus plus. So this is our final answer. Now fifth one, sin inverse x by root on sin inverse x by x square dx. You complete it. So leave it sin inverse x into x to the power minus 2 dx. This one first function because it is in this one as second. So sin inverse x unchanged, x to the power minus 2 dx, d dx of sin inverse x, x to the power minus 2 dx, total integration dx. So you complete the rest of the part. Now we consider 1, 2, 3, 4 problems. 1 and 2 exactly same. So first one, x sine cube x dx. Now you know rule, x is algebraic, this is trigonometric. So this as first function, this as second function. But integration of sine cube x, you know, you do not find integration of sine cube x directly. So we try to express it in terms of multiple angle. So sine 3x equals to 3 sine x minus 4 sine cube x. So what is sine cube x? 4 sine cube x, 3 sine x minus sine 3x. So this one equals to 1 by 4 x into 4 sine cube x dx. So 1 by 4 x, this is 3 sine x minus sine 3x dx. Now you can easily integrate it by parts. So this is first function, this one is second function. So 3 sine x, 1 by 4 outside, 3 sine x minus sine 3x. This one is unchanged. Integration of x, this is x square by 2 minus this is first function, this is second function. So 1 by 4 third bracket, x unchanged, first function unchanged, integration of 3 sine x minus sine 3x dx minus ddx of x, that is 1, integration of 3 sine x minus sine 3x dx, total integration, omitting one step here. So 1 by 4, this is C1. So 1 by 4 x into minus 3 cos x plus cos 3x by 3 minus 3 cos x plus cos 3x by 3, then total dx. Third bracket close plus 1. Now you can easily integrate cos x and cos 3x. So integrating you will get this. Now second one is exactly same. Cos square x half into 1 plus cos 2x. So you complete it. Now problem number 3 and 4. We consider problem number 4 at the beginning. So from formula of inverse circular function, we know sin inverse x cos inverse x equals to pi by 2. Tan inverse x cot inverse x pi by 2. So if we use this relation, denominator is only pi by 2. So this equals to pi by 2. And this is sin inverse root x minus cos inverse root x. Now again, sin inverse root x unchanged. this is pi by 2 minus sine inverse root x, cos inverse x, pi by 2 x. So 2 sine inverse root x minus pi by 2, pi by 2 dx. So this is 4 by pi, 2 to 4 by pi, sine inverse root x dx minus integration dx. Now sine inverse root x we have already solved it. This is our problem number 1 of this class, and this is dx. So you can integrate it. Next, problem number 3. This is most important problem for completion also. So look, e to the power sine x. This is x cos x, cos cube x cancel, minus tan x sine by cos, this is tan x, and this is sec x. We are getting this one. Now e to the power sine x into cos x into x dx, e to the power sine x into cos x into x dx, minus e to the power sine x into tan x sec x dx. So we can divide it into two parts. Now look, e to the power sine x, derivative of sine x is cos x. So derivative of sine x is cos x. So this is integrable. E to the power sine x into cos x dx. Due to presence of this cos x, you can integrate it. Sin x equals to z. So cos x dx equals to dz. So it is e to the power z dz. This is e to the power z. This is e to the power sin x plus c. So what is integration of e to the power sin x into cos x? E to the power sin x. You have to keep in mind. So we integrate this one as first function, this is second. So x unchanged, e to the power sin x into cos x dx minus d dx of x integration e to the power sin x cos x dx total integration minus second integration, make it unchanged, tan x sec x dx plus c1 plus c1. Now we have already proved e to the power sin x into cos x. It is e to the power sin x. E to the power sin x. Now minus, this is 1 e to the power sin x cos x. E to the power sin x cos x. So e to the power sin x dx. We are getting this. This is minus, and second is e to the power sin x into tan x sec x dx plus c1. Now we can integrate it. This is second function and this one is first function. So x into e to the power sin x minus, this is not integrable, minus, look, e to the power sin x unchanged, integration of tan x seconds, integration of tan x seconds is seconds, minus integral of e to the power sin x, so e to the power sin x into cos x, then integration of tan x seconds is seconds dx plus c2. So, omitting one step, derivative of e to the power sin x, e to the power sin x into cos x, integration of this is seconds. So, finally what we are getting, we look x e to the power sin x minus e to the power sin x dx minus e to the power sin x into sec x minus minus plus e to the power sin x cos x sec x cancel plus c. So this term cancel out. So finally we are getting e to the power sin x common, x minus sec x plus c. So this is to be noted. We divide it into two parts, two integral, then integral to by parts. So this integral part is cancelled out. Now we consider two important problems of integration by parts. They are of competitive exam. So problem number 2 first. So look, root over x square plus 1. Make it unchanged. This is log, this is log. We want to put it in formula of log. So log x square plus 1 minus log x square by x to the power 4 dx. It is root over x square plus 1 log x square plus 1 by x square by x to the power 4 dx. So look, this is log 1 plus 1 by x square, and if you divide by x within root over, it is x square. So 1 plus 1 by x square, then x cube dx. So this step to be noted. You look, 1 plus 1 by x square. To make it 1 plus 1 by x square, you have to divide by x square within root over x square. So this x square will be x. Then you put a transformation. Let 1 plus 1 by x square equals to z square. This is within root over. So x to the power minus 2 into x to the power minus 3 equals to 2z dz dx. Minus 2 into, so 2 cancel. So 1 by x cube into dx. 1 by x cube into dx equals to z dz by z dz negative minus z dz. 1 by x cube into dx equals to minus z dz. Now this one is root over z square, that is z. This is log z square and dx by x cube minus z dz. So z into z square, 2 log z z square log z square dz. Z square log z square dz. So minus, this is 2 log z. So z square into log z into dz. 2 log z, so minus 2 outside. So we can integrate it by parts. So we complete the rest of the part. Next, problem number 1, final part. So this is also most important problem of competitive exam. So look, x sin x plus cos x. If you take this as z and if we differentiate it, so what we are getting? X cos x plus sin x minus cos x. So minus sin x. So its derivative is x cos x. So if we put this as z, so dz is x cos x dx. But x cos x is not present at the numerator. Only x is present. So we write it as x cos x into x sec x. Because x square sec x cos x 1. Then x sin x plus cos x whole square. Then we write it in this form. X sin x plus cos x whole square into x sec x dx. Now look, x cos x by x sin x plus cos x whole square. What is the integration of this part? So we first find integration of this one. Now if we put this as z, so this is z square, this is z square, and it is x cos x dx equals to dz. So z to the power minus 2. So minus 1 by z is integration. So minus 1 by x sin x plus cos x. So we can integrate this part. So this is second function and this one is first function. So if we omit one step, this one is x sec x unchanged, integration of this. So minus 1 by x sin x plus cos x. Then minus derivative of x sec x. So x sec x tan x plus sec x. So derivative of x sec x. And integration of this, we have already proved. Integration of this part is minus 1 by x sin x plus cos x dx plus c1. So omitting one step, this is second function, this is first function. First function unchanged, integration of second. Derivative of x sec x, integration of this. Now this is minus x sec x by x sin x plus cos x minus, if you simplify it in terms of sin and cos, x sin x by cos square x plus 1 by cos x into, this will be plus 1 by x sin x plus cos x dx plus c1. Now this first part is unchanged, so no change. And this is cos square x LCM. cos square x. So this is x sin x plus cos x, and this is x sin x plus cos x dx plus 1. So this and this cancel out. So this is most interesting problem. So this bigger quantity reduced to simple one, that is 1 by cos square x, that is sec square x. So finally what we are getting, minus x sec x by x sin x plus cos x plus integration sec square x, 1 by cos square x, sec square x dx plus c1. So minus x sec x by x sin x plus cos x plus tan x plus c. So we are getting at last the very simplified form. So this to be noted, x square can be expressed x sec x into x cos x, then integrate by parts. So today, through this video, we have solved some important problem of board as well as competitive exam. I will take 3 more classes for this chapter, integration by parts. So thank you for today.